Okay, it's time. Let's get started. Good afternoon, everybody. Thanks for coming. And in this talk, I'm going to talk about through the looking glass, effective observability for cloud-native applications. Who has watched the Disney film, Alice Through the Looking Glass? Oh, not many. Has everybody watched the movie, is Alice in Wonderland? That one is better. Okay, this is kind of by the same author, Lewis Carroll. Actually, it's a sequel of the Alice in Wonderland. So it's basically Alice is going through the mirror and find out the world is completely upside down. So it's why this talk using this title, through the looking glass. Actually, in the cloud-native world, it's actually the application basically running in the cloud. If you do not go there to have a look, basically what you envisaged probably is completely different what is behaving. So that is the whole about let's go through the gateway, peek into the cloud-native world to find out the reality. So it's the kind of how the application are behaving. So in today's talk, we are going to talk about why, what, and how. And toward the end, we'll give you a quick demo. So as you know, today, the world is completely different from the world 30 years ago. Basically, we have a massive kind of computing and a lot of basically it's multi-cores and parallel processes. It's really, really complicated. If something goes wrong, it's really, really difficult to figure out which part is having an issue with. The other thing is, I heard is kind of the double sound. Did you all heard that? So, excuse me, there's echo here with that. Yeah, thank you. So it's basically the monolith. Previously, we were doing monoliths. Now we are doing microservices. So it's one application, it's become a lot of them. So it's one request that goes through a lot of different parts. So that's why if something is not behaving well, it's very difficult to work out where is the problem. So it's basically the whole application evolution and together with the infrastructure evolution make the situation even more complicated. So as you can see, sometimes it's really frustrated. So what do we mean by observability exactly? I don't know what it's me. So it's in general, observability means kind of you look at some internal state, goes beyond the internal state, and then find out that exactly what's actually happening. And in IT and cloud computing, basically is kind of, it means refer to software tools and practices for aggregating, correlating, and analyze a steady stream. And then all the performance data to help you to do the monitor, troubleshoot, and debugging. So this is what observability is about. How can we do, how can we do to create this observability, to enable this observability? So it's basically there's a few steps. First, you can instrument basically your application to collect relevant data, such as log, metrics, and also traces. And then, with all the massive data collected, and it's really, really difficult to mine the data. You can create a lot of data. However, if you don't have any external system to help you to store it, to analyze it, you cannot get sensible information from it. Again, with this kind of the instrumentation, with this kind of database and etc., help you to store the instrumentation data. Also, you will need some tools, analyze tools, to create a graph, to generate a report, so that to give you human consumable format, so that you can get sensible information from it, take some action from this data. So it's for the instrumentation. Basically, for the application instrumentation, it has 3 pillars. It has logging, metrics, and distribute tracing to create end-user monitoring and profiling data for you. So it's for logging. We know I think is most of us, like when we create application, we will do the logging, right? And most importantly, if something goes wrong, got an error condition, you will create some like exceptions, and you log exceptions. And also, if you enter one particular very important method, you have enter and entry and exit trace. And all this kind of, you print out, this is kind of the log. At some particular situation, you said, okay, I am here. This is kind of, this situation happened. So this is logging. Logging is a point time statement. Basically, is basically at this point of time, these things happened. And with the logging itself is very difficult. You have a timestamp, basically logging one particular like character of the logging. It has a timestamp associated with at this particular time, and these things happened. It's very detailed, and however, it does not span. If you want to record more kind of the duration, you will need something called a metrics. So metrics is a record, for example, the whole like a method, invocation, how long it took, and etc. So this is the metrics data. So it goes for some period of time, and then calculate, okay, what's your CPU usage, what's your response time, and also over the time, how many times this method has been invoked. So this is metrics. To summarize, logging is to a particular point, and metrics is the time duration just to cover that method invocation. We need to go beyond that, because I mentioned earlier, in the cloud native world, is one request might span to multiple like microservices. If you want to figure out some sensible like operation and sensible overview about what happened, you will need to go beyond the method level. So this is distributed tracing. So distributed tracing is distributed. So the word is mean is not only limited to a particular method, particular microservices. It goes beyond microservice. It's basically is linked to the other microservice. So this is a trace. So with these trees often correspond to a particular request. So basically, this request goes through service A, service B, and service C. So this is one trace. So this is basically is almost like when you say, oh, okay, someone traced your footstep. So wherever you go, you are traced. So this is something followed you. So this is a trace. These 4 trees, I want to kind of mention a little bit more here. So it's so here you can see this is the trees. So it's basically is one request directly goes through multiple applications. So it's a browser application, a web server, and this. So basically it's from start to finish. So this is one trees. So trees will consist of multiple spans. So span look, this is span. Span is only inside one service. So it's just one service, one invocation, one like a method invocation. So this is span. And as you can see, so here, on the top here is like a span information. It's basically all the data there. And then you will see basically trees consist of multiple spans. And in what way these spans basically linked together to form a trees? There will be many of trees, many of the spans. This is just the building blocks. This should be way you know which span belong to one particular trees. How do we do that? So this is very important to know. Span has a span ID. So you can go back. So you can see here, the span has a span, always has a span ID or name or context. And then the span has a span ID, and also you will, so this is the span, this span, that span, and this span. So in order for the span to link like relevant together, you will need a context. So this is context. So context means basically almost like a relational database or this kind of link table, right? So here, the context will contain the information about trees ID and parent ID. So basically, when the span, like this span ABC123, and then when the request go to the second one, it will have another new span DEF456. However, the context is always propagated, so that when the second span created, it will have context like contain the trees ID and the parent ID. Now you can go back. We can see here. You can see here is basically has that span has a name and also has a context, trees ID and span ID. So with this information, and you can correlate, basically correlate, you know, okay, basically this like a context, so this two purple one is belong to one trees. So the trees ID is FEF676. You know, this is kind of correlated. And then, you know, these three span belong to one trees. However, how do we know? Like we put 1, 2, 3 before DEF456. So basically, that's determined by the parent ID. So you know this is 456 parent is 1, 2, 3. So that's a queue after this parent. So this is how this was generated. So this is kind of, it's nicely generated based on this context data. So are there any tools to help us to do the observability? So luckily, we have a few tools. One tool is called OpenTelemetry. Who knows OpenTelemetry? Yeah, brilliant. Yeah. So OpenTelemetry actually is under CNCF. It's language agnostic. So it's the merge of open sensors and open tracing. So this is become the OpenTelemetry. So this is kind of the overall standard for multiple languages because it's kind of it produces portable telemetry to enable effective observability. So it has APIs, SDKs, and collection tools, and it has enable metrics, logs, and tracing. So basically, all of the observability will be provided by OpenTelemetry. So this is a graph taken from OpenTelemetry.io. So basically, in your application, you will use automatic instrumented, or you use OTel API, and together with this SDK for the implementation. And also you can put the data, basically you produce the data and put the data to the collector. And then later on the collector can push the data out to the storage as well. So this is how kind of the open OTel works. And in particularly, so it has a tracing metrics and logging, 3 things. And also it has basically come up with APIs, so you can use OTel APIs. SDK means the implementation for these APIs. And also it defines some other data like OTLP protocol and semantic convention, basically for the property name and matrix name and etc. So the component in detail, so basically it has APIs. At the moment it's still like under development. So it's tracing, most part of tracing are stable, so the API is stable. And some bit of metrics are stable, but not all of them. And also semantic convention is on the verge to be stabilized for the HTTP metrics of these semantic conventions. So there's a lot of things are still not standardized. And also the context API, so it's also some bit of context API stable as well. Also, it has a bigger extension framework, so it's define additional APIs, but not part of core APIs. Core APIs are defined by the OTel specification. And also, you have SDK, so the implementation of OTel API, and also has SDK extension, so this is kind of define additional SDKs. The other thing I mentioned earlier, because OTel is a merge between the open tracing and open sensors. So also should have a migration, path. So basically it's the bridge. So how to directly continue to use open tracing, but to be understood by the OTel collectors and etc. So there's a OTel shame. So it defines the bridge layer from open tracing to OpenTelemetry APIs. So you can use the shame library, can directly basically migrate directly from the open tracing to OpenTelemetry APIs. Similarly, open sensors, there's open sensors shame, also basically the bridge layer from open sensors to OTel API. So this is for the old applications. For the new greenfield applications, do not use open tracing or open sensors anymore. You should directly use the OpenTelemetry APIs. So the other implementation, the other tool to help you to do the observability is a macro profile. Who knows the macro profile? Okay, quite a few. That's good. So I'm very proud to announce macro profile was 6.1 was released last week, so 12th October. So we did basically a public announcement Monday this week. So this is the fully up-to-date macro profile release and also macro profile web page. So this is kind of the way I put for macro profile and enable to create a cloud-native applications. So there's a 3-layer core layer. So basically, create a REST application. An integration layer, you use a secure, resilience, documentation, and reactive, and basically it's a browse, the GraphQL. And the top layer is telemetry, health, and metrics. So it has health, it has telemetry and metrics, be able to provide help for the observability. For logging, macro profile doesn't have logging, but it defers to the any other cloud native runtimes, such as Liberty, do the logging. Some other runtimes, they also add a lot of logging, like you use Java util logging, log4j, a lot of logging framework for you. We did have a discussion in MicroProfile regarding whether to create a logging framework or not. And eventually we didn't go to create one because there's a kind of de facto standard log4j and also Java util logging already. For metrics, who knows MicroProfile metrics? Okay, a few hands. So MicroProfile metrics, basically there was an evolution happened in MicroProfile metrics. So originally it was based on drop wizard, but later on the micrometer was become very popular, and then is in the MicroProfile metrics 5.0 release, it also changed the metrics data format and also framework based on micrometer. So this is it gives you a lot of APIs, annotations for you to easily for your application to emit telemetry data. So later on I will do a demo so you can see it. So the other thing is MicroProfile telemetry. So in the MicroProfile 6.1 release, and we have a MicroProfile telemetry 1.1 included. So if you want to find more information, click on the link, MicroProfile telemetry, you can find a lot more. So in MicroProfile telemetry, so basically released, I mentioned included in the 6.1, and it adopts OpenTelemetry tracing. So this is a very different specification. In other MicroProfile specifications, normally create its own API, but in this specification, it does not create any additional APIs. Instead, it adopts OpenTelemetry tracing API. So basically, all the APIs, basically OpenTelemetry tracing APIs available to MicroProfile telemetry. And also the implementation package all the STKs and etc. So this is you might ask, if you just adopt OpenTelemetry tracing, why you create this like a spec? What additional functionalities you provide to have to be in the MicroProfile telemetry? Let's take a look. So the MicroProfile telemetry support basically 3 instrumentations. One is the manual. One is basically manual. You directly add this, basically use OpenTelemetry APIs. The other one, automatic. Automatic is a kind of great addition for this specification. Basically, all of the RESTful calls, including REST client, MicroProfile REST client, they are automatically instrumented. You do not do any single line code. It's automatically instrumented. And also, it also supports OTel Java agent. Anybody are using OTel at the moment? Only heard of it, haven't used it. All right. Okay. So it's so this is kind of the 3 flavor of the support. So in more detail, for the I mentioned earlier, automatic. So it's you don't need to do anything. Your REST request automatically traced. For manual one, you can use directly use the OTel annotations like with the spans, and also it's simplified a lot. So basically, you do not need to bootstrap, and you can directly inject OTel object, such as @inject tracer. You get hold of tracer, and you can get hold of span to add things in, add event in, or you can directly do a span or current to find out what's the current span. Who knows the CDI? CDI? Okay, a few people. So who knows auto-wired? Auto-wired? Okay, a few. If you know auto-wired, @inject is pretty much equivalent to auto-wired. So it's just inject. So this is a very straightforward. Later on, I show you some code. You will see. And the agent instrumentation. So OTel also OTel has another flavor. Basically, for the older applications, you do not access any of the util APIs. However, you can use a Java instrumentation in your OTel to trace every single operation. So this is called agent instrumentation. And microprofile telemetry also support this. So directly in your OTel Java agent instrumentation is also available to microprofile telemetry. So this is kind of the in more detail. So how can you do the kind of the Java agent instrumentation? You directly, when you start the basically your application, for instance, if you start this jar, you pass in the Java agent jar, and also you specify service name and trace exporter. And for the automatic instrumentation, you do not do anything. For the manual instrumentation, and you can do all this injection, and also you can use this annotation. Remember, with the span, you give you the span. Basically, the span will be created for that method, and also you can add the span attribute to add some particular additional attribute, or you can inject a tracer, span package, and OpenTelemetry. Tracer, you remember, you create that tracer, and with tracer, basically you can create a span, and then or you can directly get a span, and also you can dealing with a baggage. So this is how it works. So it's basically, so if your application, if you have a couple applications, one request goes like goes to the first one, and then goes to the second one is a return a response. And remember, this context is basically trace context. It carried span trace ID, span ID, and eventually, and all of the trace information can be correlated to be a single trace, and then all this trace information can send to the backend, and then you can view it via Jaeger client or Zipkin client, and etc. Okay, so this is kind of the, so far we have mentioned how to instrument your cloud native applications. Basically, in summary, you need to instrument it, almost like you add a secret agent in your application, so that can give you a lot of information to tell you how well your application is behaving. This is like if you want to get to know Mars, you have to send a space shuttle to the Mars to see, collect some samples to be analyzed. And then second one is with this data, you can send to an external system, can store or analyze it. So it's so this one you can do the basically go to the Jaeger, go to the Zipkin, and so that you can then analyze data. And for visualize, again, there's some other tools like Grafana, there's Prometheus and Kibana, and etc. Give you even produce even some more data, more graph, and you can spot some very useful, interesting trend. For example, if your credit card is used in 2 different locations within 1 second, you can automatically figure out, basic bank automatically figure out, okay, this is credit card must be stolen, something like that. So this is basically, you can monitor all this graph and take some action directly from the usage. Okay, with that, it's a demo time. I will show you how to use, I think for the OTel, so basically that's pretty much library. I will just have time directly show you how to use the micro profile to do the observability. Because of time, I have this application started, and also it's kind of started running. Basically, this application is directly to microservices. One is kind of the, so this is the graph. So directly to service, one is inventory, one is system. So basically it's basically you directly call the inventory, inventory later on call the system, and then it's you return the response. And then I have Jaeger client running, and then I will just collect all the trace data and show you how the trace was created and how much time is spent in a particular operation. So with that, if I basically, so this is the endpoint, this is inventory. If I invoke this service basically return the properties and will go through the system. If I go to the Jaeger client here, if I do that, and then I will get a final trace. As you can see a few seconds ago, I get this 5 span, 1 trace. As you can see, the 1 trace and 5 span, it says where the time spent. It tells you the service, tell you duration, and tell you the more information and the process. So now you see how the trace created, what a span is like, and how did they do it. Let me quickly explain to you. First, what you should do, basically, and you just need to enable the feature. So, a micro profile telemetry 1.0. Who knows OpenTelemetry? Okay. For the ones who do not know OpenTelemetry, just check out openTelemetry.io. Find out. So this is also we'll see you also enable the metrics. Later on, I'll show you the metrics. And then is by default, you won't get a trace. If you want to switch on the trace, basically you can see this hotel property. If you say SDK.disabled equals false, so that means enabled. Also, you declare the service name, so this inventory. And so this service inventory and enable trace, and then the trace will be enabled. So this is the REST, so basically the application. And then, as you can see here, I have a lot method here, and this method add. So this add a host name. You can see I directly use with span. It's hotel the annotation, and I added this additional host name. So this method will give me a span. Again, the list method will give me a span as well. So you can see at least 2 spans. And again, previously in that slide, I said you can inject this kind of the tracer and also span. Here, I inject the span. So the inject is from Decatur kind of injection. So basically, this is Decatur injection. So, and then you inject the trace, and here you can use a tracer, and you can get a span builder, getting properties. You can start a span. And then you do a kind of the span, make it current, and then you can add event. And also later on, you can add another event. And remember, you should do end your span. Yeah, you have to do in the finally end your span. Otherwise, your span goes outside of this method. So span should always be ended inside of this method. So you can see this is kind of the, at least the 3 span was created. So in this kind of the application, remember this get properties are for host. So this is kind of the how it works. You can see here, you can see get properties. And also you can get a system. This is a get operation, and this is add operation. And also the this one, and you can even see the if you are JSON. You like a JSON, you have JSON lava. You can see all this kind of the key value pair. So basically, it's in JSON. You can see this is trace ID. And each span, so this is a lot of span. So span, a lot of spans. Can 1, 2, 3. So all these spans, you have trace ID and span ID. 4. Remember 5 spans, yeah? 1, 2, 3, 4. And all the information there. And also, all the things has also got metrics for you. You have not even used any metrics, basically do anything with the metrics. By default, all of the kind of invocation, RESTful invocation, also give you the metrics, basically request the data. So it's also the kind of the base, quantile, and the CPU usage, and you get all sorts of metrics included, and heap memory, and etc. So this is a kind of pretty much powerful framework. So check it out, like macroprofile.io, and also you can learn more kind of the things from OpenTelemetry guides to learn about these specifications. With that, I think finals. This is what I demoed. Is you can find it from here. So it's public available. You can bookmark that and try it out. So I have talked about basically is the open source tools, and also there's some takeaways for you to do the further reading. If you want to learn more about observability, so there's more guides. So it's to help you with the health metrics and tracing and etc. So with that, I think, yeah, time up. And this is my Twitter ID, LinkedIn ID, and get in touch if you have any questions. Probably I can ask one. I can answer one question if you have. Any questions? Okay, if not, thank you so much. And yeah, find me if you have further questions. Yeah, thanks.